Thank you very much for your kind introduction. I'm excited to be here to present my remarks on spectrum monitoring. QuadSAT is a relatively young and small Danish company developing spectrum monitoring and interference location solutions. But before I start off with my remarks, I want to share two key takeaways from yesterday's CEO fireside chat, which are quite relevant for my remarks. Efficiency is sustainability. It was mentioned that the better antennas work, the fewer antennas we need, and the lesser interference we will actually experience. The other point was standardization. It was mentioned the example of mobile phones. We are quite used to traveling now. We use the same mobile phone when we travel to another country. This is not the case when we talk about user terminals, for example, OneWeb or Starlink. So this is something I also want to point out. When we address the problem of space sustainability, we often think about space debris. That's the first thing that comes to mind. Other things that gained attention are atmospheric pollution, for example, or in general the environmental footprint of the space industry. From my point of view, an often neglected point is spectrum. Spectrum is a finite resource, and spectrum is challenged by changing user requirements for higher bandwidth, lower latency in the recent years. In addition, we also witness a paradigm shift to a much more dynamic infrastructure setting. We talk about software-defined satellites, we talk about software-defined ground segments, we also talk about mobile user terminals or even ground stations in space. So we use buzzwords like multi-orbit, multi-beam, D2D, frequency sharing. So we can address spectrum in the same manner as we address orbital congestion or congestion. So spectrum is also congested and contested. Time is money, and also higher throughput is money. And this increasingly dynamic landscape challenges also the way we do spectrum monitoring. In order to achieve sustainable operations, we often think about the regulatory side and the technological side, and I want to focus on the latter one. Novel technologies can often be utilized to monitor spectrum, since you cannot manage what you cannot measure, but you can also use these technology to reduce interference by optimizing antenna performance. So this implies that monitoring can reveal the usage of the channels. Of course, filings are given. Does that mean that the frequency bands are 100% used or not? I have to admit, I have been to a conference where I was presented with some monitoring results where some channels are actually used to only 20%. You can identify free bands this way, and this supports data verification and correction. Monitoring also protects licensed users and identifies illegal users, thus ensuring compliance with the regulations. However, this dynamic infrastructure leads also to an increase in interference. So mobile antennas is something we experience more and more often. These antennas introduce a non-stationary interference. The market for what we call flat panel antennas is skyrocketing, but we are lacking a standardized approach. When we talk to our customers, what we often hear is that moving mobile interference is a huge problem. You can compare that to GPS jammers, which are installed in lorries, are driving around. So suddenly you move from a static interference setting to a dynamic interference setting. We also see that the interference between spacecraft is increasing, or between spacecraft and other airborne solutions. And also the interference at ground installation is increasing, something which I want to talk more about in the next slide. So monitoring can identify and mitigate interference, but it also can contribute to evaluate interference policies. So QuadSAT's drone-based approach technology focuses on the whole life cycle of RF. equipment in order to contribute to sustainable spectrum management. Often, during an installation of antenna equipment, steps are omitted, equipment is not validated, or calibration is only performed once during the installation, and then you neglect the possible degradation of your system. Thus, you might introduce the need for a higher link budget, or you introduce interference. We at QuadSAT, we suggest a different approach, which consists of 4 different steps: testing, validating, calibrating, and monitoring, which also includes standardization for certain antennas and constantly monitoring the performance of systems. In contrary to classical antenna calibration features or mechanisms at bore site ranges or in chambers, you cannot simulate or measure during in-situ measurements. You do neglect environmental conditions like snow and ice on radomes, which we can do with a drone-based operation. In addition to addressing the whole life cycle of the instrumentation, we can also look at different types of instrumentation. We can study single antennas, both fixed antennas and antennas on the move. As I already mentioned, the largest problem we face are antennas on the move, which are introducing moving interference. We can also study larger installations like teleports, which then might introduce interference between different antennas on their site. But we also can study the spectrum surrounding these infrastructures. Given the political situation, I think we are all aware of that. Radio transmissions provide an obvious attack surface into these installations. And by having radio spectrum monitoring solutions in place, you can actually identify and geolocate external RF emissions. You can also study full structures like oil platforms or ships, where often you encounter the same problems, interference between different antennas. But last but not least, geolocation is one of our main features. It's not about spectrum monitoring, establishing that there is interference, but also geolocation. So we can identify by using a drone-based solution and an angle of arrival, you can actually identify the source of an interference surrounding your installation. By that, we suggest that we can actually close the gap between ground-based and spaceborne RF monitoring solutions in order to have this last-mile interference geolocation. And by that, I want to conclude and thank you for your attention. I'm happy to connect. If you have questions, please find me during the coffee break. Thank you.